Viewers, in this question we are asked the decimal number 10 is represented in its BCD form as, and these are the four options which are given to us. Okay, so the decimal number which is given to us is 10, right? So we need to convert this decimal number 10 into its BCD format, right? So for 10, at first we will dissect this decimal number into two parts. That means 10 will be dissected into two parts. We will get 1, we will get 0. And we will find the BCD equivalent for 1, we will find the BCD equivalent of 0. Now here as we can see, the BCD representation is a 4-bit representation, which means that we will be getting 4 bits for 1, we will be getting 4 bits for 0. Okay, for 1 we will get 4 bits, for 0 we will get 4 bits, and if we then combine these two together we will get a total of 8-bit representation, 4 bit for 1 and 4 bit for 0. Okay, and each of these 4 bits, like this 4 bits, as I have said earlier, the BCD representation is a 4-bit representation. Now we need to know what will be the each of this individual value of this individual bits. Okay, like the bit which is present on the absolute left hand side, this bit will be the most significant bit, or MSB, and the bit which is present on the absolute right hand side will be the least significant bit, or LSB. Now we need to know what will be the individual values which is associated with each of these bits. Now BCD code is also known as 8421 code, which means that for 4 bits we are getting 4 values of 8421, which means if we write 4 bits here, this 4 bits will have an individual value of 8, 4, 2 and 1, which means if we write here, for example, if we write 1 here and 0 here and 0 here and 0 here, this this signifies that the positional weight is 8 for this bit only, and for the rest of the bits, as there is 0, we will getting no positional weights here. So for only this bit we will getting the positional weight of 8. So this will be equivalent to a decimal number of 8. Okay, so we will do the same process for this representation 1 and 0, right? So as I have said earlier, BCD representation is a 8421 representation. Now to represent 1, we just need to uh, signify that the positional weight of this position will be signified by bit 1, and the rest of the position we are not interested in that because we need only 1. So we will be writing 1 under the positional weight of 1, and we will be writing 0 and 0 and 0 for the rest of the 3 positional weights, because this 1, if we multiply this by the positional weight it is associated with, so we will getting 1, and if we multiply each of these bits with the positional weights they are associated with it, we will be getting 0, and if we add them together we will getting 0 plus 0 0 plus 1, we will be getting 1. Okay, so we can already see that if we represent 1 in this way, this is a correct representation. Now similarly we will represent 0. Now to represent 0, we are not interested in any of this value. Like in the previous case, if we write the bit 1 in the positional weight of 1 and we write 0 in all of the cases, we will be getting positional weight of 1. But in this case, if we write the bit 1 in any of those cases, we will be getting some value which is not equal to 0, right? For example, if we write 1 in 4 and write 0 in all other cases, we will be getting a value of 4. So that is not our required answer. So to represent 0, we will be writing 0 for all the cases, which signifies that each of the positional weights are associated with bit 0. So if we calculate its decimal equivalent, we will getting 0 into 8 plus 0 into 4 plus 0 into 2 plus 0 into 1, which will give us a total of 0. So our required BCD expression will be 0 0 0 0. So as I have said earlier, this is a 4-bit representation of 1, this is a 4-bit representation of 0, and then we will combine it together to get a total 8-bit representation, and that will be our required answer. So in this case our required answer will be 0 0 0 1 we represented 1 by 4-bit BCD number. Then similarly we will represent 0 by 4-bit BCD number, which is 0000. So here in this case it will be our option number C. Thank you.